All right, welcome everybody. I'm glad you're here watching the video today with us. I had a really good time making this one. And just a reminder, I'm going to continue to play the live stream video lecture at 8 a.m. every Monday, Wednesday, Friday. You're welcome to come join us on Blackboard Collaborate. It doesn't matter which section of the course you're enrolled in. Mina and I are using the same slides. We're talking about the same concepts. We do have a little bit different style, so choose whoever's videos you prefer. Coming to the live stream gives you a chance to ask questions in chat. I'll be there to answer them. You can see what questions other students have. And if you're having trouble with procrastinating at this point, this will keep you on schedule if you have to make yourself accountable and come watch the video at 8 a.m. with us. So if you're interested, please remember this is an optional extra component of the course. We're just providing this as a little incentive to keep on schedule, an opportunity to interact with other students, but the video will always still be available on YouTube. You're welcome to come watch it anytime you want. So today we're going to be learning a little bit about functions, one of my favorite topics. So we're going to learn about calling functions, using them. We'll find that functions in programming are a little bit different from the mathematical functions you may be familiar with. Let me skip down. This is what makes it my favorite lecture of the semester. We're going to make Battleship. All right, so and while I'm on the topic, please read chapter 3 of Downey's book about functions. All right, let's enough of the intro. Let's jump into this. All right, so as we get started, we're going to need a couple things for the beginning demo. First up, this is today's video lecture on the schedule page. I can see that Mina is already finished and is once again making me look bad. But we're going to need some materials from under the code directory. So click code. That'll bring up the GitHub page. We can see that Mina's work is already here. Just beat me to it again. What we're going to need though is this guest.py. So go ahead, left click on that, right click on raw, and we're going to save link as to download this file. All right, then go ahead and find where you keep your Python materials. For me, it's documents, CS220. This is lecture 5. I'm just going to save this right here. All right, got that downloaded. That's finished. Then I'm going to go to PowerShell. I'm going to navigate to documents, CS220, lecture 5. And from here, I can see that I've got guest.py installed in this directory. All right, next up, I'm going to open up Jupyter Notebook. And we're just going to do a little bit of experimenting here. All right, so there we go. Jupyter Notebook's open. I can see that I'm in the directory with guest.py. That's perfect. I'm going to open up a new Python 3 notebook to get started. In the very first cell, I'm going to go ahead and bring in the functions that are in that module. So go ahead, just type this line like it's magic, and we'll explain how it works later. From guest, now is the guest.py module we downloaded. It's in the same directory. From guest, import star. That'll bring in all the functions that were in that. I'm just going to run this with Shift-Enter, and it doesn't produce any output. It's just gone ahead and done that for me. All right, so next thing I'm going to do, I'm going to pause the video and put some text up here. One sec. All right, I just wanted to make sure all this was working, get some stuff set up. So what I'd like to do is focus here on cell number 2. I've got a couple of commands here. I'm assigning the value 0 to the variable x, so x gets 0. And then I'm calling a function, so y is equal to f of x. That's one of the functions in guess. And then I'm just writing y. This is just going to print out the value of y. Because it's the last line, it goes in this out box in Jupyter Notebook. I don't need to worry about typing that extra stuff for print. All right, and what we're going to do here is just kind of have a little fun with this. What I'd like you guys to do is go ahead, get this set up, pause the video, and do something like this. Just copy and paste this cell. Let's change the value of x. Let's try x equals 1. Yep, there we go. And then we'll Shift-Enter, and it prints out a new value. So it's going to recompute the value of the function when it gets x. So when f of 1 is equal to y, we print out y. I can copy, paste this again. We can change x is equal to 2. Can run this cell again. All right, what I want you guys to do is experiment a little bit. Pause the video, try some of these things yourself out, and see if you can figure out what mathematical function f of x is. All right, and if you kick back just watching this on mobile, you know, while soap operas are running, I'll go ahead and throw in a couple more guesses, just so that those of you guys who don't have it open can see. If we do x is equal to 3, there we go, minus 26. What are some other numbers you want to see? Should we try -1? -1 gives us 2. How about 10? minus 999. How about negative 10? Shift enter to run that. 1001. If you guessed that f of, I'm going to make this a comment, so this code is not actually meant to be run. This is the answer. F of x equals minus x raised to the third power plus 1, you'd be correct. So check this out. Let's go back here. When x was 0, 0 cubed is 0 plus 1, gave us 1 right there. When it was 1, 1 cubed is 1. Negate that. Minus 1 plus 1 is 0. 2 cubed is 8. Negative makes negative 8 plus 1 makes minus 7. All right, so I hope this, yeah, here, let's take a look at minus 10. Minus 10 cubed is negative 1,000. We negate that as positive 1,000 and add 1 to it, 1,001, okay? So it fits for all of the experiments we've done so far. All right, so next what I want to do is just show you guys something that will likely go wrong for you at some point during the semester when you're doing homework. All right, so I've got this code up here at the top. I've got x equals 3. I've got a little cell here that computes y equals f of x and prints out y. I'm just going to go ahead and execute this cell right here. So I moved the cursor up to it, I clicked on it, I shift enter, and it prints out 1001. Now if x is 3, in fact I've already done x is 3 right here, I should have gotten minus 26. Now the problem is Jupyter Notebook remembers the order that all of the cells are run in. So it did, here we go, 2, 3, 4, 5, 6, 7, 8. The last time we assigned x was here in cell 8 at minus 10. And then we came up here and I did this one, number 9. And then I ran this again. And here it thought x was minus 10. Even though in the page, in the cell right before this, x is equal to 3. I've never actually run this cell. That's got a no number right there. It's never been run. So if you ever run into some weird errors, or if you're trying to run our test.py and you get something that totally works for you, but it doesn't work on test.py, the secret is going to be to go up to kernel and restart and run all. All right, so when we do kernel restart and run all, and actually click the correct option, it goes ahead and it starts with cell 1 and executes it. Then it does the next one, executes this. Then it does this one. So we've assigned value of 3 to x. We run y equals f of x and print out y. We do get the minus 26 we'd expect. 3 times 3 times 3 is 27. Make it negative, add 1. So if you run into anything a little weird, go ahead and give that a try. That's going to be an important thing. Restart, run all. Remember that's there. All right, hopefully you guys remember this sample problem from lecture 2, where we were going through sequences of steps and just tracing through and trying to think like a computer. This robot move program was an example of using a function. So this move code box right here are some steps that are outside of the main code that we jumped to in line 2 and 5. Let me actually advance the, there, got them circled. The perform steps under move code, then continue with step 3. Perform steps under move code. Those two lines right there are known as a function call or a function invocation. So some other vocabulary about functions that are going to be really important. We're going to be giving functions values. In this case, we gave the value 2 to the function move code, stored it in that box. It's not shown in this one. And then the move code function here knew that it needed to move forward, for example, 2 squares if we gave it a 2. The value that we give the function is called an argument. And that can be stored as like in a variable, or it could be just straight up a real value, like put 2 in the moves. Inside the function, that moves is going to change names. It's going to be known as a parameter. And inside the function, it will always be a variable that's just being assigned a value from the outside, whether it's like a straight up number, a literal, or whether it's something that's already been stored in a variable. Not all functions take arguments. We're also going to learn how to ask functions questions so they can return an answer. This move code function doesn't actually give us any response back. All it does is move the robot forward. But we just saw an example of that, the f of x function that we were looking at in Jupyter Notebook moments ago. We gave that a value x, and it returned a value for y. All right, later this week, we're going to learn to write our own functions, but today we're just going to focus on using existing functions. All right, let's just take a big step back and look at some just general function concepts. So my example here, I've got some code, some more code, some code in a blue box, more dots, more code, another identical blue box with code in it. So my meaning here is that these are exactly the same lines of code as these lines of code here. So that means at some point we copied and pasted the code. That's in general a very bad idea, because suppose this was wrong and I need to make a change right here. Well, I've also got to remember to go make a change everywhere else that I copied and pasted it. And it makes my entire code longer. So one of the things we're going to do as we write code throughout the semester is known as refactoring. That's going to be the idea that we reorganize the code and take repetitive things or things that I may need to use twice and put them into functions. So once we have a function here, I've already mentioned parameters and arguments, but now that I've got a picture, so I've got my code out here on the outside. I've got some arguments. Those are the values that I'm going to be giving the function, like the x value. X in my f of x example at the beginning was the argument. I'm going to pass those arguments to the function, and inside I'm basically just going to assign the values of the arguments to these parameters. So parameters are variables inside of a function. And then once the function is done doing whatever it needs to, when we call or invoke it, it's going to return the result. And we could store it in a variable, we could print it out, we could ignore it, lots of things. I also want to point out here in my little picture, I just have a blue box. All right, I'm not actually telling you what this function does or how it works on the inside. Ask yourself a question for a second. Are you a good driver? Can you get behind the wheel of a car and drive successfully without crashing? Hopefully most of you guys are. Now ask yourself, do you have a really deep understanding of what's going on under the hood of your car? How does the engine really work? Could you identify the distributor? Can you change the spark plugs? And now ask, is it possible to be a good driver without actually knowing how the engine works? And of course it is. All we really need to know is how the car behaves. We're going to be giving the car inputs, like pushing down the gas pedal. If you know that pushing the gas pedal makes the car go faster, you don't need to know what's going on with the engine or the transmission. Just that pushing the gas pedal makes the car go faster. Functions are going to work the same way. All we really need to know are what inputs do they require, how do I give them the inputs, and what's it going to return. It doesn't matter what goes on inside this blue box to get to the answer. It could be complicated and hard. Someone may rewrite it later to make it easier and correct. And then it's going to return a value. So, yeah. Once we finish writing our function, or if we're using someone else's function, we don't actually really need to remember the details of how it worked. So this is one of the main features of functions. I can write a little piece of code that does something, and then I don't need to remember how it works. I just need to know what to give it and what it's going to give me back. So all the little details are taken care of. And this is really how the huge, gigantic software projects are written, with teams of hundreds of people. Lots of people contribute. They all write functions. Those functions are used by other programmers. And the other programmers don't need to know how you figured out to solve whatever little problem your function does in order to use your function to contribute to the entire project. All right, I was just looking at my list of vocabulary here. Refactor, change the organization. Parameters and arguments are basically the same number. This is on the outside. We're giving the value. Parameters are internally the where I store the number inside the function. They're going to return something, a return value or a result. We'll talk about this in a little more detail, but we also have the potential to have default arguments. These are values that are just put into a parameter if we don't pass anything. So in this case, I'm looking at argument 1 gets passed in, but we never actually passed argument 2, but the parameter requires 2 things. So we can assign it a default value to use if the user never actually puts anything in. We can also have something known as named or keyword arguments, and we'll see an example of this in just a moment when we talk about printing. But in this case, we can say that param1 equals something very specifically, use the name that the function uses on the inside, and give it a value, in this case arg1, and then that gets put into the correct spot. All right, so just a little bit about calling and invoking functions. First up, we always require 2 things at minimum. We need the name of the function, in this case the print. Print is a function. We've been using that for a couple days now. And when we use the f of x function, we require the f. So we always need the function's name. We also require parentheses. It's these parentheses that tell Python that this is a function. Then there's some optional pieces too. Arguments will go inside of the parentheses. Sometimes we'll have one, sometimes we'll have more. We may not have any at all, in which case we still require the parentheses. We'll just have an open parenthesis followed by a closed parenthesis. It's the signal to Python that this is a function. We also sometimes may produce a result. This is known as the return value, and we can do pretty much, we got a bunch of choices as to what to do with it. We could store it in a variable, we could print it out, we could completely ignore it, or we could even use it as the input to another function or another expression. Alright, I'm back over in Jupyter Notebook. I tweaked a bunch of the controls. Hopefully this is now big enough that everyone can see it. And I just want to do just a couple of quick demos of using some functions. Print, we've used this a bunch already. Hello /n hello world. There we go. When we print this out, Shift Enter will run this. It's going to print out hello and world. So it takes an argument, in this case this string. Quick reminder that /n will be the new line, so it remembers to go and put this on the next line down. Without that, if I just put a space in, it's all on one line. There are some others. We've also learned the type function. Type of 1 should tell me that that's an integer. Type of 1.0, 90, that's good, is a float. Type of hello is a str or string. Type of, let's see, 1 equals 1.0. What do you guys think this is going to be? Is a bool. All right, so we've used type a bunch. Those are the 4 main types we'll be using for the next couple weeks. We can store the results of these things in a variable. I can say t equals, and then I can go and grab this text right here, paste it, and now the result of this I can store in the value t. So let me run that, and I'm actually going to add one more line just to print out what t is. So it's been stored in the variable. T is printed right there. In fact, I can print t. Interesting. So it prints it a little bit differently with the print command. Here it just tells me it's bool. Heads up, it's giving me this in angle brackets. It's telling me class. It's the same thing with a little bit different structure as how it's displaying the information. So something else I can do is I can use this function. It returns the type, and I can just print it directly. So I have a function that returns something that's actually the input to another function. So the return value is the argument. I do that. This is a lot. It can be confusing for people the first time they see that I can just like chain all these things together. But you've actually been doing this for a long time when you did algebra. Think about a problem like this, 2 plus 3 times 4. If you do a problem like this, first thing you do is you're going to say, well, the 3 times 4 comes first. So I'm going to do the multiplication, and I get 12. And then I'm going to say 2 plus 12. I'm going to use the result of this computation as an argument for the next addition. And I'm going to get 14 when I'm done with that. 14. Let's see. Oh, but that's a syntax error. You know what? Python will just do this for me. I don't need to do that. There we go. In fact, it's completely possible for us, now that we have functions, to write our own programming language that doesn't use any operators at all. Consider this same problem, 2 plus 3 times 4. I've got 2 functions in that guess module that we imported at the very beginning. This won't normally work, but I've got an add and a multiply module. They are function. And modules are just collections of functions. That's what we brought in, is the ability for Python to access these functions. So add just takes 2 parameters and returns their sum. Mult takes 2 parameters and returns their product. So if I wanted to do this same problem, I need to do the 3 plus 4, 3 times 4. So I'll be doing mult 3 times 4, and I need to separate all the arguments with a comma. So I'll have this, and this is going to be what I want to add to the 2. So there's the arguments for my add function. Those will go in parentheses. Then I'll have add. I kind of did this in a backwards order. I started, knowing that I was going to do this multiplication first. Maybe another way to think about it would be if I were to write the same line in a different order. I'm going to be adding. It's a function. I need my parentheses, and I need two things. Okay? It takes two parameters. The first one here is going to be the number 2. And then this second thing over here is going to be the 3 times 4. So that's a product. So I'll be pulling in the mult function right here. That's going to take two things also. I need to separate them with commas. And those things are 3 and 4. And then I made it kind of ugly with some extra spaces. So there we go. Now it looks pretty good. And when I run this, I can see that the result is 14. All right, for my next example, I'm going to jump over and use idle. I know that switching from one tool to another is confusing and slows down the learning process, and I only do it when I have a really good reason. So first I'm going to just go, oops, I need PowerShell. And this is the one that's running my Jupyter Notebook. I want to leave this running. So I'm going to instead right-click there and open a new PowerShell. There we go. Change back to my directory. So that was Documents, CS220, Lecture 5. I can see, yep, there's guest.py. I'm in the correct one. Next, I'm going to run idle, and I'm going to create a program in Python called parrot. Parrot.py. So I'm going to add that .py extension to tell it that it is a program. If you're on a Mac, you may need to type idle 3, and that'll bring up momentarily idle. If this is not yet working for you, come to office hours and we'll get it all straightened out. All right, the reason I wanted to switch to idle is I really prefer the way the input from the user, as it, if I'm the user running my code, it lets me type stuff in compared to Jupyter Notebook, because those cells are designed to be like continuously, like one cell, then the next cell, the next cell. In this case, I'm going to write a complete program. You run the program, have it get some input, then the program will end. And then I'm going to want to start at the beginning again. So that's why I'm switching to this technology. All right, hopefully this is all large enough that you guys can see it. So right here, it tells me that I'm editing parrot.py. After I get some code written here, I'll click run and I'll run module. But for right now, let's go ahead. Parrot is going to be really simple. It's a virtual parrot, not a real one. Only thing it's going to do is it's going to ask for some input. The command to get input from the user, it's a function, is called input. And it'll take that input, and what we'd like to do is print it out. All right? So pretty straightforward. So when we get input from the user, I need to store that. I'm going to put it in a variable. We'll call that words. Gets whatever the result of the input function is. And then we'll just print out those words. That should be the minimum we need to just get started and see where I've messed up. So I'm going to go click run. I see that run module is F5. So I'm just going to go ahead and use F5 from now on to run this. Save before continuing. Okay, so I can see that it's got a restart and I've got a cursor here. Now we didn't actually give the user any decent instructions. It just is a blank cursor. So it's confusing. It's not telling us what to do. So we'll go ahead and we'll just type something. This is how the user input function works. They type something, I push enter, and then the blue text there is from the print. So it's printed out the same thing that I just gave it. So that was confusing. It's not exactly what I would love to see. Let me rearrange these windows a little bit. It would be a much better program if it told us what to do. So input can actually take an argument also, say something. There we go. We'll put a colon, a space, because the user will type right after that, and I want it to look good. Let's try this again now. So I'm going to just click F5, save, yes. I need to set it up to automatically save next time. All right, say something. What's another good pirate phrase? Bury them deep. And the parrot replies, bury them deep. Ooh, that's actually good. And right now in my virtual parrot, it doesn't actually say it's a parrot. Let's go ahead and upgrade this a little bit. We'll have the parrot says, and then, so that will close up this first block of text there, and then we'll just add words to it. How's that look? All right, let's run this. F5, save, restart, say something. Walk the plank. Parrot says walk the plank. All right, that's looking pretty good. All right, guys, I've got a trick question for you. In this print statement right here, how many arguments am I giving the print statement? Think of this as an exam question. It's one of those things, it's hard to Google, it's hard to do an experiment to figure it out. You've got to know your stuff, which is why it's going to be brilliant for like the midterm coming up. How many arguments do we have here? All right, make a guess, commit, and the answer in 3, 2, 1 is 1 argument. So when we have a string of text like this, and we use the plus operator to concatenate it, Python is going to go ahead and simplify this as much as possible before it does anything. So it's going to end up with 1 string of text, and that will be the argument. Now, it's totally possible to give the print statement more than 1 parameter. I can just put a comma in and separate them. Let's go ahead and just see what happens when we do this. All I've done is remove the plus, put in a comma, and I need F5, save and run. Let's see, what else do pirates say? Dead men tell no tales. Okay. Now I just want to point out too that this is a little, I should have done the same thing so I could see. There's exactly 1 space right here. If you're following along at home, you can like hover over with your cursor. In this version, there are 2 spaces. One of them comes from right here, and one of them comes because when Python takes more than 1 argument in a comma separated list, it puts in its own space. So that's where that second one comes from. Pretty soon, we'll talk about how to change that and how to control what exactly the print statements look like. But more on that in a moment. All right, I want to explore using input just a little bit more. So I'm going to go ahead and create a new file. I'm going to save this, save as. Let's call it calculator.py. And all it's going to do is add 2 numbers. So we're going to say input needs to be a string, enter x. We'll get a number from the user, and then we'll get another number from the user, enter y. We'll go ahead and prompt them so they know what they're supposed to do. We're going to want these later. As it is right now, if I just type input, Python is going to forget it. I need to say store that in a variable. Let's call it x. Store that one in a variable. All right, I've got a good feeling about that. And then the sum of x and y is x plus y. All right, the odds of me typing that correctly and getting this to work on the first try are pretty low. I'm going to push F5, save and run it, and figure out where I've made all my typos. All right, enter x. So let's go with 2, enter y, go with 3. Okay, guys, what is the sum of x and y? Just make a guess. Commit. Write something down, say, I think it's going to be, and I'm going to push the go in 3, 2, 1. The sum of 2 and 3 is 23, of course. Interesting. I also have 2 spaces right there. That's because I'm using commas. I'm going to go ahead and get rid of that one. Let's move that over. So now it'll look good next time around. Now what's going on here? Why did I get 23 instead of 5? The problem is what I'm really doing is, I'm going to make a comment here, I'm adding strings together. I'm adding string 2 plus the string 3 because the type of the input, the type that input returns is always a string. So let's go ahead and just verify that. I'm going to print out the type of x right here, and then we'll print out type of y right there, and we should see that it tells us they're both strings. I'm just going to go ahead and run this, and we'll enter an x. We'll go with 2, on the wrong screen, 2, enter y, 3. It says they're both strings. That means when we did this x plus y right here, I was taking a string 2 and a string 3, and when I combine 2 strings with the plus operator, that means concatenation. So we're going to need to upgrade this a little bit. We are going to need to turn those strings back into integers so we can add them. All right, the technical term for this is known as casting. So I'm going to do that right up here. So I'm going to say that x is equal to, and the command to turn something into an integer is just int. It's awesome. The name of something you want to turn it into when I'm casting is the name of the function. So, and I'm going to use x again. I'm going to use x on both sides. So it'll take this string value x, quote to quote, turn it into an integer, and store it back in the same place. So the type of my variable x just changed with this line right here. I'll do the same thing for y equals int y. All right, I'm going to run this code. Save, runs it, enter x, 2, 3. It's going to tell us they're both integers. And now we see the sum is correct for our calculator. We got 5. All right, guys, let's try and break this. I really enjoy this part of writing programs and testing. Enter x. Let's try 2. So I'm putting this in as a string using characters. And 3. There we go. And what we see here is, of course, it breaks. And we do get this error message. Traceback is the beginning of an error message, most recent function call. So the important thing here is, where do we start seeing a problem? And that is in line 3 right there. And it prints out the line. This is the one. The error is invalid literal for int. So this is the casting to an integer. So it actually needs to take a number with like real decimal digits. It can't take this input string of text. If we go back and look at the code, it says it's line 3. Just while I'm here, if you guys are using idle, so line 3 is right here. If line numbers are not turned on, and I don't think they are by default, it's under options right here. Right here, the middle option, hide line numbers. Because mine are turned on, it says hide. If I click it, it'll take them away, and then I can show line numbers. So easy peasy, right there. All right, let's try and break this one more time. I'm gonna just push F5. That'll run it. Enter x. What about 1.0 and 3.4? Another error. All right, let's take a look at this one. It's actually the same error message, invalid literal for int with base 10. So what we really have here are floating point numbers, not integers. So to fix that, what I really need to do is take this text that I'm inputting. Right now it's an int, and we'll upgrade this to a float. Now this should work with both integers and floating point numbers, because they can both be stored in floating point numbers. All right, I'm just we'll run that one more time. Enter x 2.0, enter y minus 3.6. And then it says class float. So we did successfully convert them. We'll bring that. Oh, there we go. I guess full screen. And then we can see the sum of 2.0 and minus 3.6, and that is the correct answer. All right, enough of that example. I moved back over to Jupyter Notebook. I really only wanted to use idle for the examples that had input and the things that are larger program style things like the Battleship game. But for this exploration, I want to just jump back over, use Jupyter, so it lets me save everything. I can put it online. I suspect I'm doing the same example as Minet will, so we'll probably just use her version. It's already there. But if there's significant differences, I'll put mine up. So what I want to do now is just a little more exploration with print. So if I do print, a moment ago I told you it can take more than one argument. So if I print out numbers 1, 2, 3, shift enter that, there we go, prints 1, 2, 3. Now we have some power over how this looks. I can add the keyword argument sep, short for separator, equals, and then I can put in whatever separator I want. Here I'm going to go ahead and use the comma. So when I didn't use anything, the default was just a space. When I change this to a comma, it's now printing them out with a comma separator. If I can do comma space, run that. So this separator lets me change what goes in between items when I have more than one argument to this print function. So that's going to be very useful for us. Another really useful one is end. So I can just add another comma, add another argument. This is a keyword argument because I am saying the keyword equals something. That equals is my big clue that this is a keyword argument. The first three here, the numbers 1, 2, 3, these are known as positional arguments. We don't need to give it a keyword because it's the first thing here, the second thing here, the third thing. Python knows what it is and what it needs, how it's to be used because of where it is in the sequence of arguments. And all the keyword arguments need to come after all positional arguments. All right, so I've got separator here that changes what happens between things. And there's an end that changes what happens at the end of the line. So if I run this, I've just changed the end from, well, I guess it's the new line, to a period. So check this out now. If I were to go, I'm going to keep that one, make a copy, print this down here, and I'm going to add another statement, print 4, 5, 6. We'll go ahead, we'll keep separator equal to the comma space, and end equals the period. All right, let's see what this looks like. In this case, I've got 1, 2, 3.4. So the period was the end of that first line. And then 4, 5, 6. It didn't actually add the new line this time through. So you may have guessed it, but the default value, remember functions have keyword values, parameters, and default parameters. The default parameter for end is the new line. And that's why if I were to do this, actually, yeah, let me demo this without any of these default. We'll use the default values because we won't tell them what we want. If we do that, it just prints 1, 2, 3, and then on the next line 4, 5, 6. The default version is the new line. That's the backslash n character. So if I want that behavior, I need to go ahead and add in my own backslash n if I'm revising this. So let me run this block again, and now we should be able to see that it's printing 1, 2, 3, 4, 5, 6 on 2 separate lines. I think that's a pretty good introduction. We will talk a whole lot more about these keyword, positional, and default arguments as we start to write our own functions and learn to use each of these features in great detail. All right, so for my final demo today, I want to make a little version of Battleship. We're going to use input, and we're going to use all of these functions we just learned about in print, the print options, the separators, the end, to recreate Battleship. Now this version, I hope you guys aren't embarrassed, but it's going to be the minimum viable product that we could reasonably pass on and like show our friends and not be embarrassed, 1 week into class. So our version of Battleship, when kids get together and they play Battleship, they have these boards like this. There's little ships on the board. One player will say they will choose some coordinates and bomb that coordinate. And then if they hit, if there's a ship there, the opponent tells them you hit, and they get to put a little red peg, and then they take turns guessing and trying to figure out where the ships are. Our version is going to have one ship. We're only going to let them take one guess. The ship is only going to be one space. It's smaller than the tiniest submarine. We're not going to let it move around. We're going to fix the position, and our grid is going to be based like this. The top left corner is going to be 0, 0, and we'll have increasing right will be increasing x, and going down will be increasing y. And we're just going to use periods for the graphics, for the pegs. So it'll have horrible graphics. What we're going to do though is when the player decides where they're attacking, it's going to go ahead and write in a 0 if they miss and a 1 if they hit. Okay, so I'm going to jump over, because this is a complete program, I'm going to want to run it from the beginning many times. I'm going to go use idle for that. I believe I already have it open. Yes, here's my parent program. Instead, I'm going to use file new and file save as. We'll call this one battleship.py. All right, cool. All right, so first up, I'm going to want to draw some pegs. So we'll be printing out some periods. There we go. There's the first row. Let me just copy this, and we'll paste it, paste it, paste it. There, now we've got some pegs. Let's go ahead and run this. Save it. All right, just reconfiguring idle so it don't have to prompt me to save every single time. And I want to rearrange the windows so they're nice side by side looking like this. Maybe we'll move this over a little bit more. That looks good to me. Okay, so we can see that we've printed out a bunch of rows of pegs. But over here, this was not done in the best way. I copied and pasted. Anytime I find myself copying and pasting, there's almost certainly a better way to do this. So let's go ahead and we'll make this a little more general. First, I'm going to be printing, let's just go with one peg. And then, let's see here. I need to know how many pegs are in the row. And we'll go ahead and use that text multiplication. And let's just say there's 8 pegs in a row. And we'll try that. What's this look like? So F5, it's restarted. There, I've got one row of pegs. And then if I want another row of pegs, I can, let's see here. We just multiply that by, let's see, it's an 8 by 8 grid. We'll just multiply that by 8. We'll run that again. There we go. Now I've got enough pegs, but there's not rows. They're all in one row. That's because I need to put a new line in right here. Plus quote backslash n end quote. And we need some parentheses around this. There we go. So now it'll take the period, make 8 periods in a row, tack on a new line, and then that's going to be multiplied 8 times. So let's see what this looks like. That's the wrong command. There we go. There we go. Gorgeous. Now we have a beautiful Battleship grid. I did some things I'm not super happy with here. I hard-coded the 8. So let's go ahead and switch out the 8 for length and width. Width, length equals, and equals. And then we'll just go ahead, we'll say those are, let's go 8, and just so they're a little different, we'll make them 10. And then the width is how many dots are in one row, and that is the, wait, let's go with height. Height is much better for something that's vertical like this. All right, running, there it is. Let's just change that to 18 and make sure it still looks good. Yep, got wider. And I think for this board, we'll just go ahead and keep it at 8. Now, we're gonna need a ship. So let's go ahead and add the ship in. We'll put the ship, and like I said, we're gonna hard code the location of the ship. We're just gonna stick that, or hide it right in the middle. Well, the x coordinate will be 4. Ship y will be at 4, hidden in the middle. And then we're gonna need a guess from the user. So we'll go ahead and guess x. We'll get something from the user using input, and we'll prompt them to enter your x guess. All right, and then after that, guess y equals enter your y guess. Lost an R there. All right, let's give this a try and see what it looks like. So I'm just gonna hit F5 to run this. Enter your x guess. We'll guess 4, and y guess is 4. That would look better if we put a colon and a space. Colon and a space. Wow, I'm having trouble typing. There we go. Okay, so that's gonna look really good. Now, one of the things is that when we are writing some code like this, if I have to enter a guess every single time, it's gonna really slow me down. So what I'm going to do instead is just hard code my guess right here. So I'm going to guess 1, and then I'm going to put a pound sign to make the rest of this a comment. And I'm just going to add a big to do. That means I need to delete that and go back to enter your guess. So the user guess is there. But this is going to speed things up. So Mike, don't forget that at the end. This is one of the things when I teach this live, I run out of time and I never get a chance to put that back. All right, the next thing we're going to need to do is actually take the location where the user guesses and either put in a 0 if they miss or a 1 if they hit. So to do that, I'm going to need to break this problem down into, I really, 3 pieces should do well. So if the user guesses, so I'm looking over here, if the user guesses that square right there, I'm going to need to print out these first 2 rows of dots. And I've got some code that does that already. Right there, it prints out dots. I'm going to need to print out this row, and if that happens to be where the ship is, with a 1, or this row with a 0. So that's printing this row. And then we need to print out the rest of these dots. And we've got some code that prints out dots already, so we can use that. So I'm just going to break this down into step 1. These are going to be the rows before the guess. And then step 2, how about the guess row? The row that they guessed. And then step 3, the rows after the guess. So yeah, let's just go ahead. We'll make this, we'll do this in a couple steps. So here, I've got some code that prints out some dots. We'll just copy paste that right there. I've got some code that prints out a block of dots. We'll use that right there. And then in the guess row, I need to print a 1 or 0. Let's just print 0 for right now. And that'll be my guess row. All right, I'm going to go ahead and run this and see what it looks like. There we go. Here's the restart. This is everything it's done. I've printed out a bunch of rows. It's too many. I know that. And we've printed out the 0 there. That's working. And these are the rows after the guess. All right, perfect. This is a great start. Now we just need to tweak the size of these rows. So that's going to be right here. Instead of printing out height, height is 10, it's printing out 10 rows. If I'm guessing row 2, I need to print row 0 and row 1, because remember this corner is 0, 0. So instead of height, what I really want is, let's see, is it guess Y? Is that going to work? Let me just run this and see what that looks like. Yeah, guess Y prints out exactly 2 rows. Perfect. And then on the other side of things, I've got 10 rows total. Row 0, row 1, row 2 is where they're guessing, and then we need 3, 4, 5, 6, 7, 8, 9, and 10. Let's see, this should really be height take away guess Y. I got a typo here. I just forgot the parentheses. So it's doing this multiplication first, and then it's trying to subtract a number, a string, subtract a number, and that's not a valid option. So we'll get some parentheses around that. So let's see here. 0, 1, 2 is my guess. Row 3, 4, 5, 6, 7, 8, 9, 10. That looks pretty good. I think that's going to work for me. All right, guys, I just went back and looked at the description of the problem. If I have 10 rows, I've got rows 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, not a 10th one. Row 10 would be the 11th because I'm starting counting at 0. So yet another, keep track of how many mistakes I make. I'm going to go ahead and put in a -1 right here. Run this again. And now I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 rows, just like I want. And they're numbered 0 through 9. All right, it's looking pretty good. I've got a couple of issues though. I've got a blank row right here. I need to take care of that. And that's coming from this line right here where I'm printing this row of blocks before my 0 row. So what's going on here is that I'm printing a new line every single time I've got my row, print a new line. And it's also got that default end line that we're putting in. So what I want to do to fix this is just add my own custom end. And in this case, I'm just going to let it be the nothing. So let's see if that works. There we go. That has now gotten rid of that blank, the blank line. All right, we're getting close. We're getting close. So next what we need to do is figure out how many dots to print before the 0 and then how many dots to print after the 0. We can do this in a couple steps. So we'll do dots before. So this is just going to be print. I need dots and however many I want. And let's see, how many do I want? So if the user is guessing 1, I still need to print out row, like column 0. So I think what I really want here is just guess X. Let's see what this looks like. Yep, there we go. So it's printed out 1 dot right there. I've got the same problem. It's put in a default new line right at the end of this. I'm going to go ahead and do the same thing I did above and just make the end the nothing. Try this again. There we go. I've got the first dot. It's printing the 0. And now I need the rest of the row of dots here. So just need some more dots. Times, let's see here. We've got width minus guess X. So that'll be, if I've got a width of 8, I guessed 2. I take that away. That should be 6 more dots. Wait, I guessed 1, didn't I? What's this look like? Does it needs parentheses? I'm getting there, guys. Run that again. There we go. All right, interesting. This row now has a new line I've got to take care of. Overlook that. And equals quotes. F5. There we go. Perfect. I do have an extra dot here, though. I guess I also need the subtract 1. Oh, yeah, that makes sense. Okay, so I've got the full width. I take away however many we guessed from the beginning. I also need to take away 1 more for that square right there. And do that. There we go. Perfect grid. It's looking good. I'm guessing that position. Let me go ahead and just make some little changes here. Instead of guessing position X is 1, let's go change that to a 4. verify that it moved over. Let's make the y 6. Verify it moves down. Okay, it's moving around. Things are looking pretty good. All right, so now the next thing I want to do is I want it to change from a 0 to a 1 if we actually hit. Yeah, later on we're going to learn about conditionals and how to do, pretty elegant stuff. And for now, we're going to need to just do this with some math. So here's what I'm going to do. I'm going to just declare a variable hit and say this is, it's going to be a Boolean variable. So we'll just say guess x exactly equals ship x. If that's true, and so that will mean that the x coordinates are matching, and guess y exactly equals ship y, then this entire expression will evaluate to true. If either of these are wrong, x coordinate or the y coordinate are wrong, then hit will be false. So, and then we can take that value. Okay, let me quick open up a new PowerShell. Jump into Python, and we can say cast true. We can take Boolean values and turn them into integers. True, just like that. And it's going to tell us that true is always 1 and false is always going to evaluate to 0. Okay, so if you ever have any doubts, you want to just like make a real quick check, open up terminal or PowerShell, type Python, and you are good to go for your like one-line experiment. So now I'm going to jump back over to Battleship, and I'm going to take advantage of this and just recast hit as int hit, like that. And then instead of printing this text right here, quote, 0 quote, I'm going to print hit. Okay, so if I run this, right now my ship is at 4.4. I'm guessing 4.6. When I run this, I messed up somewhere. Timeout. Oh. Equals. There we go. Should give me that 0 right there. If I go ahead and change the guess to 4.4 and run this, it should print a 1 right there. So it looks like it's working. All right. Last thing I want to do is really upgrade. So to be honest, when I score a hit, getting a 1 there is not quite as satisfying as if that were a star. A 0 or a star. I'd like to make that little upgrade right here using the functions we've just been learning. So instead of hit right here, I'm going to do one more thing. Hit is now a number. It's either a 1 or a 0. I'm going to say that symbol equals star, or it's a 0. Let's go capital O. That looks better, I think. So we'll either put in a star or put in a capital O. And what I can do here is, if it's a hit, I can just multiply that by hit. So hit will be 1. That gives me exactly 1 star. If it's a miss, then that'll be false. This will give me a 0. And so I'll be multiplying that star by 0. So hit is a 1 or a 0. When I multiply the symbol here by 1 or 0, I'm either going to add 1 to symbol or 0 of those. In fact, let's... and then the other way I need to look at this is if it's a miss, then I want to add a 0. So if hit is 0, I want to add 1 right here. And if hit is 1, then I don't want to add anything. I want the exact opposite. I want to flip this hit around. And we can do that using some of the math functions we've already learned. So here I'm going to multiplying by hit mod 2, or it's hit plus 1 mod 2. Because I can take advantage of this odd even testing. So if it's a hit, that means that it's going to be true. So I'll have a 1 right here. Hit mod 2 will have a remainder of 1. Yeah, I think I just got a good feeling about this. That I need to switch it from an odd number to an even number and then take the modulus. Oh, I don't know. We're just going to experiment running the code. So it's printed a 1 right there right now because I hit. Let's move my guess somewhere else. We'll try right there. and now it's printing a 0. Oh, wait a second, Mike. You've got this symbol you just computed, but you didn't replace it in here. You're still printing 1 and 0. So on line 20, where I'm printing stuff out, that's where it needs to go. All right, let's try this again. There, it didn't print anything. My symbol somehow failed to get to this one. So I think I do need that +1. Run this again. There we go. So now it's printing my 0, or capital O. If I move it back over to the direct hit 4, run this again. Yep, now it's printing the star. Personally, I find that so much more satisfying. This math was kind of ugly though. I've got some extra parentheses. I can clean it up a little bit. Yeah. So if this got a bunch of extra spaces in there too, and clean that up. Yeah, hopefully this made sense. The way I was using the modulus to decide if it's odd or even, it was the wrong parity, so I added one more to it, and that let me get either a 1 or a 0 to multiply by this. And this gave me a 1 or a 0 to multiply by the star. I was just having a good time. All right, guys, this is going to do it for me. We are ending lecture on a win with the star right there. So have a great day.